Okay. So today the goal is to study the derivative of inverse functions. So I will write here well, remember that we have covered basic differentiation rules, power rule, and then chain rule, product rule, quotient rule. We already started covering derivative of trig functions. Now we want to add to this list. Today we will add one rule, which is basically how to find derivative of an inverse function. And then we will use that to find derivative of inverse trig functions. So when you're leaving today, you will add 6 more differentiation rules to your table of differentiation, plus the theorem that tells us how to find derivative of f inverse at a given point. So let us start. Let f be an invertible function. Invertible function means that, well, either based on our restriction or our theorem, means that it is one-to-one function. But I also want this to be differentiable and differentiable. This could be only at one point, or in general, differentiable in general, we can. Now, I want to see how differentiability of f is translated or transferred to differentiability of f inverse. The fact says that if f is differentiable at a point, say, f inverse of a. The reason I'm writing that, I'll tell you a little bit more, but remember that f is defined on the range of f inverse, and f inverse is defined on the range of f. So if f is differentiable at that point, and one more condition, I'll write this condition, leave some space here. It is an important condition, but I want you to see this. I want to be able to find derivative of f inverse at what point? At that given point A. There is a simple proof that if f is differentiable and this condition happens, then f inverse is differentiable at the point A. That's a simple thing. You just need basically to look at the graph of f inverse, which is just graph of f. You find reflection with respect to y equal to x. If it is nice at that point, in other words, if it has a tangent line, the reflection also will have f tangent line. We have to be careful about 0, not 0, and that will appear here. So now I want to tell you what is that derivative. It is differentiable, but what is that derivative? To find that, we use the simple fact that if I compose f and f inverse, what do I get? Just x itself, yes? They cancel each other. This does go like that. Now, if I find derivative of both sides, dx of f inverse x is equal to dx of x. What is derivative of x? What is derivative of x? 1. Okay. What is derivative of f O F inverse. This is the chain rule. Remember, when you have two functions composed, if both of them are differentiable at nice points, then the composition is going to also be differentiable. And we know how to differentiate. We differentiate the inner one, and then we differentiate the outer one, but we plug in the inner one and evaluate it at that point. We are looking for derivative of F inverse, and it must satisfy this equality. Then why don't we just solve it for that inequality? It says that F inverse, derivative of F inverse is given by 1 over derivative of F, but you have to evaluate it at the right point. What is that point? You have to evaluate it at F inverse of X. That is what we are looking for. So F inverse prime at point A is given by 1 over F prime. But F prime must be evaluated where? At F inverse of A. It's not 1 over F prime at X. It doesn't make sense if I say that. Because, see, F prime is defined at A means that if I want to see A as the value that I can use it for F, I have to go back using F inverse and then plug it into F. And that is the only meaningful way of plugging different values into F and F inverse. And it comes into the play, and this is the rule we have. Derivative of F inverse is 1 over derivative of F. But what point evaluated? That's evaluated at F inverse of A. Now, looking at this formula, or looking at this proof, you should be able to see that there is a condition there. I cannot do that calculation all the time. I have to be careful. What would be that condition? What would be that subtlety that I have to keep an eye on? Yes, please. The denominator cannot be equal to 0. If it is 0, then I'm failing here. Everything will be bad. So that means that the condition I'm going to add here is that if F prime evaluated at F inverse of A is not 0. That's the only way that 1 over will make sense. So that condition is coming very naturally into the game. Any questions? Any comments? Let us then do this. Evaluate F inverse prime at given point A, knowing that F F at 6 is 2. F prime at 6 is 1 over 3. And here A is 2. The second example is F at 1 is 0. F prime at 1 is negative 2, and A is 0. So I'll do this one myself, and then I'll let you do the other one. So I'm looking for F inverse prime. The notation is a bit cumbersome, but there's no no other good way for me to do it. So derivative of f inverse at what point? At point 2. F inverse prime at A is 1 over f prime but evaluated at f inverse of that point. It's 1 over f prime, but there's only one thing I can plug it in there. I'm not allowed to put 2 there. I should bring 2 back using f inverse to the x values of the input values of f and then plug it in there. What is f inverse of 2 in this case? 6, because f at 6 is 2, f inverse at 2 will be 6. So I'm looking at f prime at 6. And f prime at 6 is 1 over 3. So 1 over 1 over 3 is 3. Just as a warm-up, do that one yourself, please. Quick. And I think you should be able to do it in 45 seconds.
F at 1, or is it 0?
F at 1 is 0, and f prime at 1 is negative 2. Okay. We are looking for f inverse prime at 0. It is 1 over f prime at f inverse of 0. But f inverse of 0 here is 1. Yes, so we are looking for f prime at 1, and that is negative 2, or the derivative of f inverse would be negative 1 over 2. I think I will do this example. We still have time, and I like these 2 examples because it's giving us a bit more of practice on the specific theorem. I have table of values for x, for f of x, for f prime of x. Let's assume that f is invertible, and then the question is, what is f inverse prime at 0? What is f inverse prime at 1? What is f inverse prime at 2? Sorry, do I have, no, I think I should start from, what I'm doing here? This is 1. This is evaluated at 2. This guy evaluated at 3. And f inverse prime at 4. So f is an invertible function. It's differentiable. And we have those values given in the table. Can you basically find the f inverse value table or derivative of f inverse and f inverse itself? So we need to evaluate derivative of f inverse in 4 points. 1, 2, 3, and 4. How about I give you 90 seconds, and I'm hoping that in this 90 seconds, you should be able to do at least 3 of these values. Go ahead and talk to a person sitting next to you if you feel you don't know how to start. Go ahead, please. Well, in all these cases, the key point is the formula we have over there. So I want to find f inverse prime at 1. It is 1 over f prime at what point? Not at 1. It is at f inverse of 1. So f inverse of 1. What is f inverse of 1? What's f inverse of 1? 4. I'm not asking what is f at 1. I'm asking f inverse of 1, meaning that what is the value that f sends 4 to? In this case, what is the value that f sends to 1? In this case, it's 4. So I have 1 over f prime at 4. And f prime at 4 is 2. So that's how I will get that. F inverse at, derivative of f inverse at 2, it's 1 over f prime. But what point? F inverse of 2. F inverse of 2 is, f inverse of 2 is 1. Why? Because f sent 1 to 2, so f inverse of 2 will be 1. And we are trying to find f prime at 1, which is negative. The same story, 1 over f prime at f inverse of 3 is 3. And we have f prime of 3 is 4. What about f derivative of f inverse at 4? 0. Okay, here if I do that, I'll get 1 over f prime of f inverse of 4. What is f inverse of 4? F inverse of 4 is 2, thank you. And f prime of 2 is 0. This is exactly what, oh, I didn't write this completely. We should make sure that whatever we are supposed to put in the denominator is not 0. But that is 0, so that means that f inverse is not differentiable at x equal to 4. I love this one more example that I have here. And then we will jump into the trig inverse functions. Inverse trig functions, I should say. Okay, tangent line to the graph of f at x equal to -1 is given by this equation. Find the tangent line, or find the, well, I can actually do this. Find the derivative of f inverse at -2. What I can promise you is this, that to solve this example, you don't need anything but that formula and understanding how the tangent line works. I can promise those two. Now, you should promise me that you will spend 90 seconds to think about how things are working in this specific example. Don't waste your time looking at me or on board. Talk to someone. Even if you start with a small thing, that is much better than doing nothing. Okay? Talk to someone or do it on the board, on the paper. Go ahead, 90 seconds starts now.
Inverse this, inverse this. Like trying, you think? Yeah.
I should be starting.
Solve for X.
I should start.
Yeah.
20 seconds left.
She knows all the lines.
Okay. Can I hear any starting point that you can share with me? Yes, please. Yes.
Plug in -1 into the tangent line. You can get a friendly that occurs on the.
That's the very nice starting point. Look, my graph is like that. At -1, I have a tangent line. Means that my line, whatever it is, must cross or must have this point. In other words, as your friend said, when I plug in -1 into the tangent line, the y value should be f at -1. So then we know from this that f, the function itself, at -1 is 5 times -1 plus 3, which is -2. That's the first thing. We know what is the y value of function at -1. What else I know based on the tangent line? Yes, please.
Derivative of the tangent, and then we can just find that f prime of
You made it more sophisticated and complicated. Instead of we know the slope of this is the derivative at, yes? Or what you said, you can take derivative of this or find the slope. That must be derivative at -1. So based on that, we also know that is that. Now I have everything that I need to calculate f inverse prime at -2. Why? Just based on the formula, I should have f prime at f inverse of -2. What is f inverse of -2? -1. So I have, I'll write a bit down here, f prime at -1. What is f prime at -1? 5. Thank you. That's how you find that thing there. Isn't that a nice question? I love that question. Any comments, any question? Yes, please.
Can we take the derivative of y equals 5x plus 3?
No, okay. I said you don't need to take derivative. You know that the slope of tangent line is the derivative of function at that point. The slope here is 5. So 5 is f prime at -1. The slope of a straight line is the derivative of the equation that gives us that straight line. So you can either know the format of your linear equation and say, oh, this is the slope, or you can differentiate and 5 is your slope. That's basically what you have. Any other questions? Any other? Yes, please.
Information to get the original equation of the graph.
I'd love to do that, but I now am running late. How about after the class, you come and I'll tell you how that works, yes? I think I may also have a proof of this thing based on the graph, just by looking at the graph of function as a video. I will check it. If I have it, I'll post it on our page so that you can look at it. Okay, so we did all those things for one important calculation. What is that calculation? I want to find what is derivative of sine inverse. Yes, please.
About the last,
Sure, yes, please.
why didn't we just find the inverse of y equals 5x plus 3?
You can do that. The only problem is that you still need to check this point somehow. Then, yes, that will. So in other words, you know how we go to the inverse, the graphs, how we go to the inverse function graph by finding reflection with respect to y equal to x. The tangent lines also go to the tangent line by reflecting with respect to y equal to x. That's why if you change y and x here, you will get tangent line for the graph of f inverse at point -2. Yes, that would also work. Okay, I want to find the derivative of this guy. Well, this is inverse of sine. So then I'm trying, should I do this one? Yeah, f of x is that. So now we want to find this. So f inverse prime at point x is 1 over f prime at point f inverse of x. So sine x is my function. Yes? What is derivative of sine x? Cos x. So cosine, but this time I'm evaluating it at f inverse, which is sine inverse of x. Well, that's the derivative. That's correct statement, but it's not complete statement. What I mean is that, remember I asked you sometime like 3 weeks ago, questions like, what is something like this? Yeah? Do you remember that cosine of sine inverse? And then you could simplify without knowing what the sine inverse of that, we could evaluate that. Now I want to do the same thing with this expression here. So I take then I take cosine of sine inverse of x. Yes? If it was sine of sine inverse, it would be easy. Yes? If it was sine inverse, then they would cancel each other. However, in this case, I have cosine here. How can I turn cosine to sine? Pardon? How can I turn cosine of an angle and write it in terms of sine of that angle? Yes, please.
The symmetry.
The Pythagorean theorem. I like to call it Pythagorean theorem. So in other words, cosine of theta squared plus sine of theta squared is equal to 1. Or I can try to solve it for the only issue is this. When I'm trying to solve it for the cosine, not cosine squared, then I take this square root, but it could be either plus or minus of that square root. We will resolve that issue, but for now, we have to keep that plus or minus. Sine of sine inverse x is x. Now I have 2 copies of that multiplied. So I get plus or minus. For now, I don't know. 2 of sine inverse of x, yes? Everything is good here. The only thing is that we should decide, is it plus or minus? Now, before I do that, is there any questions so far? Any questions so far? Just simple calculation. Remind yourself of we did calculations like this, yes? Now, I am looking at the sine inverse of x. So x is a number between -1 and 1, yes? Sine inverse of x would be an angle between what and what? Do you remember? The one-to-one domain. Yes, please? Negative pi over 3 pi over 2. Sorry, pi over 2 pi over 2. So theta, if I take this one as angle, so this must be either, it must be bigger than negative pi over 2 or less than pi over 2, yes? Now, my angle is in the either this quadrant or that quadrant. And I'm trying to find cosine of that. Is it going to be positive number or negative number? What should you remember? All students take calculus. So everything is positive here. So cosine will be positive. Students take calculus, or cosine is positive again. So either that interval or that interval, cosine is going to be positive. So cosine of such theta is always positive. So I don't need to be worried about positive, negative cases. It must be positive. We are almost done. We simplified this, and we got to that. very similar game you need to do for tan, for cosine, for secant, for cosecant inverse functions. And if you repeat the same things, I will write derivative of these guys. And then we can then differentiate a few more functions. Derivative of sine inverse x, we just showed that it is 1 over root 1 minus x squared. Derivative of tan inverse. By the way, derivative of tan inverse is easier than what we wrote, what we did for the sine inverse. If you put everything right, it will be right away, and you will find 1 over 1 plus x squared. Or x squared plus 1, doesn't matter. Then you have secant inverse of x. Secant inverse has a nice story that when you do those calculations, you notice that, oh, at some point I should take everything positive, but this x can be negative or positive. That's why in your book, the derivative is 1 over absolute value of x times root of 1 minus x squared. The coversions of these ones, cosine, has the same with negative sign. Cotan inverse has the same with negative sign. Cosecant inverse has the same negative sign. I won't write those ones down. But they're exactly same things, but with negative one. Cosine negative here, cotan inverse negative here, cosecant inverse negative there. But instead of that, and I trust that you can find those ones from the book, you have to know them. I'm not writing down doesn't mean that you don't need them. You need to find them, but they're very similar. Instead of that, I will write the chain rule versions of these ones. Remember, in the case of chain rule, we still have the same derivative evaluated at inner function, but you have to also multiply the derivative by the derivative of the inner function.
What about the cos?
I said the co-version of these ones are the same thing with negative sign. So cosine inverse is the co-version of sine inverse, which will be negative here. Tan inverse, cotan inverse is co-version of tan inverse, will be just negative there. And cosecant inverse will have negative. Okay? And again, you have to find it from your textbook and write them. For tan inverse, I get u prime 1 plus u squared. For secant inverse, you get u prime over absolute value of u, u squared. Wait, I made a mistake here, sorry. This must be, oh, change this, please. This is, I made a mistake. That's x squared minus 1. I get so obsessed with absolute value, I forgot to put the right thing there. This is u squared minus 1. Sorry. Yes, please fix that. Yes, please.
Why is the sine inverse of u 1 minus x squared? Why is it not 1 minus y?
Oh, u squared. See, I'm tired. I need to go home. Oh my God, all these things are being recorded now. That's awful. Okay, they will fire me for this. Okay, any questions, any comments other than, should I memorize these? Yes, you are now my differentiating machines. You have to differentiate 10 functions when you wake up, 10 after your breakfast, 20 with your lunch, and 25 before you go to bed. Don't go. Do these ones and then go.
I did negative one. Negative one. Okay, that's it.
I will give you 1 minute, and then I will use the other 1 minute to write the final answers there. Go ahead. You have to be able to differentiate. Use all the rules. Use the other differentiation rules and find the derivative of these functions. No simplification is needed. Yes.
Is that an example? Like cos?
Oh, no, that was left there. Oh, I can write that. How about sine or cosine inverse of 0.75? What is the derivative of this one? Let me do quickly these ones. F prime x is derivative of first one. Derivative of e to the power x is ex times the second one plus the first one itself times the derivative of sine inverse, 1 over root 1 minus x squared. Derivative of, remember chain rule plus power rule, u to the power n, the derivative is n, u to the power 1 less, times derivative of secant inverse, which is 1 over absolute value of x root x squared minus 1. G prime x, arctan or tan inverse, arctan is the other name for tan inverse, of derivative of this thing. Then that would be u prime over 1 plus u squared. But u prime here, you can do the work. You need the quotient rule here. It will give you negative 2 over x plus 1 squared. What is derivative of cosine inverse at 0.75? What is derivative of that? That's the simplest function you can get. It's constant function. The derivative is 0. Have a great day. Come back tomorrow. We will learn more about differentiation.